This video is designed to help you solve any exam question about logic gates, truth tables, or circuit diagrams. The obvious and most required thing that you're going to need is to know what the gates actually look like. So these are our logic gates. You've got the AND gate, the OR gate, and the NOT gate. You need to know how to draw them and how to recognize them, just in case they are on the exam. You could get a very simple question where it asks you to label the diagram, where you just have to say what each particular gate actually is. But you also need to recognize what the symbol is so that you might be able to draw the truth table. If we take a quick recap on what each gate actually does and the truth table for each one. So a NOT gate takes any single input and gives it a single output. The output is always the opposite value to the input. So if the input is 1, the output is 0. If the input is 0, the output is 1. And if you take a look at the truth table in the corner, you can see the input and the output. So a truth table shows any possible combination of inputs and what the resulting output would be. In this case, with the NOT gate, there is only one input. An AND gate shows that we take two different inputs and we give one output. And we need both inputs to be 1 to get the output to be 1. Otherwise, the output is 0. And when we take a look at this particular gate, you can see that we've got input A and input B. And in the truth table, we've got input A and input B. So all the truth table is showing is any possible combination for the two inputs. So you can either have both of the inputs are off. You could have B is on, but A is off. You could have A is on, but B is off. And you could have both of them turned on. If both of them are turned on, then the output will be on. But any other combination means that the output is off. Very similar to the AND gate, the OR gate also has two inputs, A and B, and we can see in the truth table the possible combinations, which is 0, 0, 0, 1, 1, 0, and 1, 1. So every possible combination that we can have. This is the first time where I could tell you a little cheat or a trick to make sure that you've got all of the different combinations. What you do is you start from 0 and you count in binary. So if you imagine that this is our binary table, you might have done this before where it counts from 1, 2, and then the next one would be 4 and 8 and so on. Now in this particular case, we've just got 1 and 2. If this is 0 and this is 0, then that totals 0. Then this one would add to 1 because the 1 column is filled in and the 2 isn't. The next one down would add to 2 because the 2 column is filled in and the 1 column isn't. And the next one down is 3 because the 2 columns are filled in. So essentially this is 0, 1, 2, and 3. We are counting in binary as you go down. And if you do that with any number of inputs and count in binary, you will get every combination for your inputs. Now with the OR gate, we can see that we just need one of the inputs to be true or both of the inputs to be true. So it's one input or both inputs are turned on and the output will be turned on. Let's use this example to show how it actually works. So at the top we can see that we have a NOT gate. And what we're going to do is show the impact of actually turning the switch on. So this switch at the moment is not turned on. That means that it's a 0 that is going into the gate. So 0 is for off. And as it goes into the gate, we can see that the bulb is turned on. So at the moment, we've got 0 coming in and 1 coming out. So 1 is on and 0 is off. So when I flick the switch to 1, so this is now 1 for on, you can see that the outgoing output is off because the bulb is not lit. Now if we look at the next gate, this is AND gate, so we've got two switches here and they are both set to 0 at the moment, and we can see that the bulb is turned off. So if we turn A to on, you can see that the bulb is still turned off. If we turn B to on, you can see that the bulb is still turned off. But if we turn both of the switches on, A and B are on, so the bulb is lit, and that's why it's called the AND gate. Now finally, if we go to the last one, we are looking at an OR gate, so we can see that A and B are both off at the moment and the bulb is off. Now with the OR gate, we just need one or the other or both to be turned on. So as soon as I turn the A switch to on, the bulb is lit. As soon as I turn the B switch to on, the bulb is lit. And I can also have both turned on and the bulb is lit. So one or the other need to be 1 for the output to be 1. So we're going to take a look at our first exam question, and I'm going to teach you another little trick that's going to make things much easier for you. So first of all, we have got our circuit diagram, and we can see that our circuit diagram has got two things in it. First of all, we have got our first gate here, and you will notice that our input is called P and our other input is called Q. Now often in the exam this might be A or B, or it could be any real letters. It's just labeling the inputs that are going in. So this is our first gate. Now by now you should know that that gate is a NOT gate. So we know that whatever is coming into this is going to be reversed. Then we also know that this gate is an AND gate. So therefore we're going to need both of these inputs to be true for this to be true at the other side. So what we're going to do is, first of all, we're going to make sure we've got every possible input in this table. So they've tried to be very clever here and make sure that you can't just memorize a truth table. They've put in 0 0 and the next one down should be 0 1, but they've done 1 0 instead. So what we're going to do is just make sure we do every possible combination. So now we've got both off, one on, and then we need both of them to be on. Remember, 1 is on and 0 is off. So at this point we've got our first section of the truth table filled in, and that's going to give us a mark out of 3. At this point we need to fill in this last column based on what the output is going to be. Now what they've tried to do here is they've put not P and Q into one column. So what we're going to do is we're going to do a little cheat. So we've got PQ, I'm going to call it R, and I'm going to put a little R here, and that is going to be the output of this gate. So whatever the output is here, we're going to record in a little column, and we're going to call it R. So in this R column, we are going to use the NOT of P. So sometimes I like to write above the column whatever it actually is. So this is the NOT of P. So the NOT of P is going to go into this column here. So we're going to take whatever P is and we're going to reverse it. So P is currently 0, so that's going to become 1. Then when it's 1, it's going to be 0. Then when it's 0, it's going to be 1. And when it's 1, it's going to be 0. So now our last column is actually going to be R and Q, because R is going in and Q is going in. So we're just going to look at these two columns instead. So we're going to look at this column and this column and use that for the last bit. So our last column is actually it's actually R and Q. And we're going to put that in. So we look at these two columns and we only look for the AND logic. So 0 and 1 is definitely 0. 0 and 0 is 0. 1 and 1, so they're both turned on, is a 1. And the last one, 1 and 0, is a 0. So you've now got your marks for this column, and this column is all 3 marks completed. And that little trick will really help you with any of these logic gates and the circuits. Just add in your extra column to try and catch out. Try and make it simplified when they try and catch you out in this method. So this is one of the more challenging questions where we are asked to draw a circuit from a boolean expression. So this here is a boolean expression. It uses boolean logic to basically map out what a circuit will look like. Now, what we're looking for usually in this type of question is we're looking for the letters like A, B, C, D, and they are going to be our input into the circuit. And on the left hand side, we are looking for a different letter, and that's going to be the output from the circuit. So the first thing that you do is look for how many inputs are going to go into the circuit. In this case, we've got 3. You can also look for the words or, not, or and you'll know how many gates need to go in. So we've got 3 inputs and 2 gates. So what I've done earlier is I've already put these ready to go in. So I've got my 3 inputs to go down the left hand side, and that is what is going into the circuit, and P is our output to go on the output section. So in the brackets, just like with maths with your order of operations, we've got B and C is in brackets, which means we need to do this first. So B and C is going to use our AND gate. So B and C are going into the AND gate. So I'm just going to put those next to the 2 inputs to the gate. Now A has got the word OR written next to it, so we know that the OR gate is going to be attached. However, we also have B and C going into the OR gate as well. So we need to put some lines in that are going to connect all of these together. So we need a line that's going to go from A all the way into the gate, and we need another line that is going to go from the output of our AND gate into the OR gate. So I'm just going to line all of these up so that they look nice and neat. Obviously, if you're just drawing this by hand, it's way quicker and way easier for you to do. So now what you can see is a rough circuit diagram, including the gates that we have used. So we've got our AND gate, so B and C, and we've got our OR gate, so A or B and C, and that's how you do it. You have to go through the logic circuit, look for how many inputs, look for which gates are going to be used, and try to place them in the correct position. Now similarly, you can be asked to draw a truth table from a Boolean expression, or usually more often is from a circuit like shown. So if you can see this circuit, you need to get prepared for how to put this into a truth table to show all of the possible outcomes. Now I've got a little trick for this that is a little bit like a cheat to allow you to do this. First step that we're going to do is we're going to add in an extra column into our truth table. So we've got A, B, C. What I'm going to do here is label this as D. So we're making D the output of this particular AND gate here. So the AND of B and C is D. And that way we can think about what the output is over here by comparing A and D, the OR of A and D. So we're going to put that into a table and it'll make a lot more sense. So we're obviously going to need 4 columns for the 4 inputs and then 1 for our output as well. And then when we're going down, you need to think about how many possible options we can have. So I'm going to start off with just 8 because that's the maximum I can do as an automatic setting. And I'm just going to put nice and simple borders in so we can see what's going on. Okay, so now what we do is once you've drawn the table, now a lot of the time this is already pre-drawn or populated on the exam paper, but even if it wasn't, you would know how to do it. So we're going to put A, B, C, D in, and then P. So I'm just going to colour these three in a slightly different colour because these are all inputs. So they are all at the beginning of the circuit. Now this is the little trick. So to have every possible combination of all of your inputs, what we're going to do is we're going to count in binary as we did earlier on. So we're going to have in binary, we're going to need 0, 1, 2, 3, 4, 5, 6, and we're going to end up needing another row as well for 7. So now what we're going to do is we are going to put all of the numbers in binary. And if you're still a little bit confused by this, when we're putting a binary byte or nibble together, it goes from 1, 2 and 4 when we're counting in binary. So far we've got 0, then 1 in binary is going to be 0, 0, 1. 2 in binary is this column filled in and the other's empty. 3 is 1 and 2 together. 4 is 1, 0 and 0. 5 is a 4, no 2 and a 1. 6 is 4 and a 2 but no 1. And then 7, we just need another row underneath. So I'm just going to add another table row underneath. And to make 7, we need 4, 2 and 1. And the reason why we've stopped here is as soon as you get to where it's all ones, you know that you've done it. So if you've counted correctly until you reach ones across all of the inputs, you know that you've got every possible option that could happen. If this confuses you in some way or you can't quite get your head around what I've just done, you need to maybe go back and watch a video about binary and how to add and subtract binary. But that is how to count in binary. Another way you could do it is just basically work out every possible combination that you can have. Usually you're not going to have any more than 3 inputs, so that is something that you can kind of work your way through. Right, so for D and P, we can now work these out using a little bit of logic. So we know that D is the AND of B and C. So we're going to do B and C is what the column D actually is. And P is going to be the A or D. So we're going to do A or D. So once you've got to this point now, it's incredibly simple if you know the logic rules for this. So B and C, the only time we're going to put a 1 in this column is if the B and the C are both a 1. So you can quickly just go down the list and say, well, 0 and 0, no. 0 and 1, no. 1 and 0, no. 1 and 1, yes. 0 and 0, no. 0 and 1, no. 1 and 0, no. And 1 and 1, yes. So that column is now populated. So we can kind of ignore everything that's come in the middle here. We're just looking at A or D. So we just need A or D to have a 1 in for this to be a 1. So the first one there isn't. Second one there isn't. Third one there isn't. Fourth one there is. Fifth one there is. Sixth one there is. Seventh one there is. And eighth one there is. So that is the column completed. This is the one that you get the marks for. This one here is the one that you get the marks for. And this column, technically you don't need to use it. But by doing it that way, you are guaranteed to get it right. You can't really make a mistake by trying to work out in your head if you do it this way.